this problem, we are given that Athena randomly picks 7 letters, one at a time, with replacement from the 8 letters in the word pantheon. Let P be the probability that at least one subset of a chosen letters can be permitted to spell a name, Athena. Compute 2 to the power 18 times P. Now notice that this is the word P-A-N-T-H-E-O-N. The letters in this word are all appearing once, with the exception of what? N. So the probability of each letter appearing will be 1 on 8. However, N that appears twice, its probability will be 2 on 8, and that is equal to 1 on 4. Now take note of this because we are going to use this in our calculation. That means Athena is supposed to choose 7 letters, right? Of which a subset of those letters should be able to contain the letters A, T, H, E, and E, such that it can be permitted to spell a name. That means we know that these 6 letters are fixed. A, T, H, E, and then N are fixed. And we have 1, 2, 3, 4, 5, 6. So the 7th letter can be any letter, of which we don't know. So let's do case by case analysis. In the first case, let's suppose that our 7th letter, let's suppose that we choose A to be our 7th letter. That means we are going to have 3 A's here, right? So A, then T, H, E, then N. So the probability for this event, of course, is going to, this implies that the probability for this event is going to be, how many letters do we have? We have 7 letters here, but don't forget that there are repetitions. So we take 7 factorial divided by the repetitions. And here we have A repeating thrice, and that is 3 times. Then we multiply by the probability of the individual letters, which is 1 on 8 to the power 6, right? Because the individual letters are A, T, H, E, right? There are 6 letters, and individually they are all, the probability of them appearing is 1 on 8. But for the N, don't forget that its probability is 1 over 4. Now notice something. 7 factorial over 3 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. That is how we do factorial. Then 3 factorial is 3 times 2 times 1. Multiply now. Notice that 1 on 8 is the same as 1 to the power 2/3 times 1 over 4 will also be 1 over 2 to the power 2. Now look, this 3 times 2 times 1 cancels this, and we are left with 7 multiplying 6 times 5 times 4, right? Which is equal to 840 times. Don't forget we have to the power 6. So this is going to be, when I take the reciprocal of this, I'm going to get 2 to the power minus 3 multiplying 6 times 2 to the power negative 2. And this will be 840 times 2 to the power minus 18 times 2 to the power negative 2. Of course, in indices, when the bases are the same, we add the exponent. So we are going to have 2 to the power minus 20. However, this 840 can also be written as 2 times 10, 210 times 4, multiplying out 2 to the power minus 20. And this is 210 times, of course, the 4 can be expressed as 2 squared times 2 to the power minus 20. And we are going to have 210 times 2 to the power negative 18. Then finally, we have 210 all over 280. So in the first case where the letter is A, this will be a probability. Let's consider the second case. In the second case, we can have our 7th letter to be either T or H or E. That means that we can have this in 3 ways, right? In 3 ways. So let's assume that we choose T, but don't forget that this can happen in 3 ways because we have T, H, and then E. That means that our set will be A, then T, assuming that we are choosing T, then we have H, E, then N. And those are 7 letters. So the probability is going to be 7 factorial over the repetition. We have 2 A's and then 2 T's. So 2 factorial times 2 factorial, multiplying 1 on 8 to the power 6. That's the individual probabilities for each letter. Times for the N, we have 1 on 4. The probability is 1 on 4. Right. So with this, 7 factorial is usually 7 times 6. times 5 times 4 times 3 times 2 times 1. All on 2 factorial is 2 times 1 times another 2 times 1. Then don't forget 1 over 8 can be written as 2 to the power negative 3. I showed you in the previous one. Then 1 over 4 will be written as 2 to the power negative 2. Of course, look at this. This one cancels this. And we have left with, when you multiply 7 by 6 by 5, by 4, and then by 3, then you divide by 2. You are going to have 1260 times 2 to the power negative 18 times 2 to the power negative 2. And that is 1260 times 2 to the power minus 20. But 1260 can also be expressed as 315 multiplying 4. And you can use your calculator to check. Or you can multiply these two. And the result will be 1260 times 2 to the power minus 20. And of course, this is 315. The 4 can be expressed as 2 squared times 2 to the power minus 20. And by the law of indices, we know that this is going to be 2 to the power minus 18. And finally, we have 315 over 2 to the power 18. So for the seventh letter to be either T, H, or E, we are going to have this. But don't forget that this can happen in 3 ways. So we multiply it by 3. Then in the third case, we can consider our seventh letter to be N. This implies that we are going to have the set A, A, T, H, E, then double N. So we are going to have this. Then the probability is going to be 7 factorial on 2 factorial times 2 factorial, then times the probability of the individual letters. But don't forget that now, since N is double, it means you are going to have 1 over 8 to the power 5, right? And for the N, the probability will be 1 over 4 squared, because N is double here. So we reduce each of the probabilities of the letters by 1. That is why we have 1 on 8 to the power 5. Of course, when you expand this, we have already done this in the previous one, right? 7 factorial over 2 factorial times 2 factorial. That's what we solved here, and we got 1260 times. Of course, this can also be expressed as 2 to the power negative 3 multiplying 5 times 2 to the power negative 2 multiplying 2. So we have 1260. This will be 2 to the power negative 15 times 2 to the power negative 4, right? And by the law of indices, we have this to be 2 to the power negative 19. Of course, 1260 can also be written as 630 multiplying 2 times 2 to the power 19. So let me continue from here. Now, from indices, we know this 2 is to the power 1, but mostly we don't write. So when we apply the law of indices, we are going to have 630 multiplying 2 to the power 18. And that will be 630 all over 2 to the power 18. So that is for the third case. The last one is the fourth case. That is when the seventh letter can either be P or O. So let's assume that it is P, then we have our set AA, T, H, E, and then P. Don't forget that this can happen in 2 ways, right? But I'm just using P to show you the illustration. So the probability is going to be 7 factorial as usual. Now, there are only 2 repetitions over 2 factorial times the individual probability of the letters, 1 on 8 to the power 6. Then the fourth one, of course, the N letter, which is the probability is 1 on 4. Now, 7 factorial over 2 factorial, so 7 times 5 times 6, times 5 times 4 times 3 times 2 times 1. Then the 2 factorial is just 2 times 1. Don't forget this is times 2 to the power minus 3 times 6. And also multiplying 2 to the power, the 1 over 4 is 2 to the power negative 2. Now this 2 times 1 will cancel this here. So we have 7 multiplying 6 times 5 times 4 times 3, which is going to be 2,520 times 2 to the power 18 times 2 to the power negative 2. So finally, we are going to have 2,520 times 2 to the power minus 20. That is using indices here. But notice that now 2,520 can be written as 630 times 4. And you can verify that with your calculator. multiplying 2 times 2 to the power minus 20. Of course, the 4 can be expressed as 2 to the power 2 times 2 to the power minus 20. And using indices, we are going to have 630 times 2 to the power minus 18. So finally, we are going to have 630 on 2 to the power 18. But don't forget that with the letter P or O, they can happen in 2 ways. So we multiply this by 2. So finally, the probability is going to be, now let's go back. In the first one, we got 210 on 2 to the power 18. So we have 210 on 2 to the power 18. Plus the second case, we had 3 multiplying 315 on 2 to the power 18. So 3 times 315 on 2 to the power 18. Plus in the third case, we got the probability to be 630 on 2 to the power 18. So we have 630 on 2 to the power 18. Then the last case, we have 2 multiplying 630 on 2 to the power 18. When you factor out 1 on the 2 to the power 18, then I'll be left with 210 plus 3 times 315 plus 630, then plus 2 times 630. Of course, let me do it step by step so that we know that this will be 210. Then we have 3 times 315. Let me use my calculator. Sorry, this is 210 plus 945 plus 630. And I think this is going to be 1,260. Let me confirm with my calculator first. Yes, that is it. Then now we add everything in our bracket. So 210, let me use the calculator, 210 plus 945 plus 630 plus 1260, that will be 3045. And don't forget that the question told us to compute. Let me go back to the question. The question says we should compute 2 to the power 18 times P. Now we have found P, that is our probability. And P is given by this. So 2 to the power 18 times P is just going to be 2 to the power 18 times P is 1 on 2 to the power 18 multiplying 3045. And clearly you can see that this cancels this right here. So finally our answer is 3045. So that is the value of 2 to the power 18 multiplying P. I hope you enjoyed this session. Thank you very much.
Hey, this is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.